Very warm welcome to everyone. So let's quickly move on. So in this very first session, we'll be discussing that what exactly you're going to learn in this session. So as you can see over here, first of all, what we're going to learn in plumbing industry or in this plumbing. So you can see over here, I mostly follow is the IPC standards. So I'll be dealing with this course mostly with the IPC standards. I'm taking most of the course. I'll be dealing with the IPC standards. That means I'll take the reference of that. And I'll try to design the project. Like example, if I say either I go with the pipe sizing, either I go with the tank sizing and all this, I deal mostly with this IPC standard because technically I have worked more in this. So I'm having much exposure to IPC standards rather than any other standards. Now don't get confused. Why? Because I know that you people are from different regions and from different countries. So they might be having a different codes, what they follow, or the standards. So see, standard means just you get a reference from it or the recommended values to design, right? So now don't get confused that what is that and what is this, because that standards and codes is being developed as per that region. So what I'm trying to say here is try to get the concept. When you get the concept, you can apply the same procedure or the same scenario. See, the procedure is same for whatever you deal up with it. Okay, like the designing pattern is one and the same. Only the values might change because you're following the different code or the standard. It based on the, I can say, the region where you are located or as per the projects what you are dealing up with. Okay, I will be dealing or training you with the maximum things with IPC standards, that is international plumbing codes. But what exactly you're going to learn in plumbing, that is different thing. Or I said the very last thing that you're going to deal up with the IPC standards. But in this case, let me tell you. So we are going to learn the designing in the plumbing system. But where exactly we do lie or we do fall under. So this plumbing, what you people have opted or what you people are interested to learn, like now this course is a part of building service. That is nothing but it's called as M.E.P services. M.E.P services is nothing but the building service. So in this building services, you are doing a part of building service because M.E.P is complete service, I can say, for the building with respect to the mechanical and electrical engineers. Okay. If now, just remember, we will be in this program or in this course for plumbing. I'll be using in most of the sequence or most of the cases, I'll be following one standard, that is international plumbing standard. Okay, so I'll be using that. And this, apart from this, you'll be seeing or you'll be getting the softwares like AutoCAD and pipe sizing you'll be getting from Excel program. So that means we'll be using this Excel program for the pipe sizing. But before that, do not get confused. I'll be giving you manual pipe sizing also, because if in case, if your company does not have an Excel sheet or Excel program, then it's difficult for you. You will be blank then. So we'll be training you for the basics. Then we'll be training you for the manual pipe sizing. So then you can easily relate this with the Excel program. Then I'll be dealing with the pump sizing again with the Excel program. Okay, so these are some two Excel programs what I'll be using in plumbing. And apart from this, I'll be dealing with one complete project, that is Villa Project A, and Villa C will be given you for the practice. Not only A also is given, but Villa C will be also given for the practice. Villa A, I'll be doing it completely. And this will be dealing up with how to deal up with the pipe size, okay, and the tank sizing and number of things, whatever the major things. And in plumbing, you know this, there are three major things I can say. One is pump, one is water tanks, and one is pipe and piping. Okay. So we'll be learning this as per IPC standards, and we'll be taking this reference, we'll be doing one complete villa project. Now, what are you going to learn? As I said, plumbing is divided into two parts. So very first module, what you're seeing is the water system. In water system, you are having number of chapters. There are 14 chapters in water system. In the module 1, I can say. So the very first chapter is nothing but the introduction or the basics. Like in this, we'll be learning about this. What is introduction to this? We are introducing to the building service. That is nothing but M.E.P. Then we'll be knowing this. What is plumbing? Then what is plumbing and what is plumbing system? Then what are the classifications of plumbing? That means how it has been divided into two categories. Then we'll be seeing about what are the different societies as a basics, I'm saying, because there are not only IPC, there are number of societies or application, I can say, okay, or the handbooks, I can say, that is IPC, UPC, ASHRAE standards, NPC, NBC, public health engineering. Yes or no? Everyone? Anyone aware of this? Yes? You guys can answer. There is nothing, no restriction. Okay. So this is what we'll be seeing. What are the different societies or applications over here? Then while we seeing this, what is the need of this codes? So we'll be seeing over here why this codes has been needed. And after that, we'll be dealing up with what kind of fluid we are using here. Like here, the fluid is water. So we'll be seeing or having some information about the water in general, like what exactly is water and all this, how it is being made and all this, how it plays a vital role in our daily lives, and what is the importance of this, and number of things we'll be seeing. When we are done with this, from here, the chapter 1 starts. That is, what is plumbing fixtures? So in plumbing fixtures, we'll be seeing, as of now, just remember, fixture is something I can say in general. I don't want to define right now. I'm saying plumbing fixture something that is nothing but I can say like WC, laboratory, showers, bathtub, and all these. These are all plumbing fixtures. In short, a plumbing fixture is something which is an exchangeable device which demands water, and at the same time, the water needs to be drained out from that fixture to maintain the healthy and good atmosphere inside the building. Yes, everyone. So we'll be seeing what are the different plumbing fixtures, the chapter number 1. So we'll be reading out and we'll be seeing why it has been used, what is the purpose, and which fixture demands what kind of water, that is cold water or hot water, or demands cold plus hot. We'll be seeing that. After that, we'll be learning about the chapter number 2. In the chapter number 2, you people will be coming across the plumbing equipments. That is nothing but the pumps, I can say, or unit water heaters, or central electrical heater, solar water heater, and all the pumps, and grease interceptors and grease traps. So these are the things what you're gonna learn in this. Okay, so why we are dealing with this? Because if we know this, if we make the background right now, so we know this, what is the purpose to have these kind of stuff in this. So then what we can do, we can later on, if we know the basics of this, then we can know what is the reason to have this. Then you can find out, or you can do the designing for that. Okay, based on that purpose. So we are trying to build up your basics or your ground so that you can proceed in future for the designing part. In the chapter number 3, you will be dealing with pipe fittings and accessories. The pipe fittings is something, for example, if you want to connect 2 pipes, so you need a coupling. So these kind of thing, or elbows where is a change in direction. So these are the pipe fittings, what we're going to learn or what we're going to see. So we'll be seeing there are a number of fittings over there, like elbow T, reducers, cross, union, XYZ. So mechanical steel. So these are all fittings over here. Once we are done, why it is being used, what are the materials, and what is the purpose to have this? What is the impact while having this fittings connected to the piping? We'll be seeing this. And you can see it's chapter number 3, pipe fittings and accessories. Accessories is something where you can access easily, like increase or decrease the water flow, you can say, or completely shut off. So that is referring to the valves. So you'll be seeing number of valves over here, different valves in short, like ball valve, gate valve, angle valve, and globe valve. So these are the things what you'll be coming across. So you can see NRV and flexible pressure gauge. So these are all coming under, you can see from here, all the accessories over. Okay. Apart from this, the chapter number 4, you'll be dealing all about the pipe material. So pipe is something which is a conveyance of the fluid from one place to another place just to deliver to the fixture what it is demanding, so that it has a convenience place for a human to live for. So that is what we'll be dealing up with, or we'll be seeing what are the different categories of the pipes which is being used in the plumbing industry. Basically and technically, there are only 2 families, that is metallic and non-metallic. Right now, non-metallic is completely taken over metallic, but in some cases still rarely, but as per the application or as per the fluid what you are dealing up with, what is happening over there, I can say that still in some cases metallic pipes is still used. Yes, everyone. Yes or no? So we'll be seeing that. So we'll be seeing this, what are the different categories, or what are the different types of material. So there is some pipe materials which is not compatible with hard water, and there are some pipe material which is not compatible with soft water. So we need to know that. Unless and until we don't know this, then that is very difficult for us to take a decision. Because if I say you in simple words, for example, if I'm trying to transfer a hot water from one place to another, and if that pipe is not capable enough, okay, that means it loses its elasticity, I can say, or it is expanding by means of that temperature, then it is not recommended. So where we can make our mind, or where we can take decision, if we have the information, okay, that this pipe is compatible with hot water system, then I can opt that pipe. Okay. Likewise, if I say you, for example, if some pipe is not compatible with hard water, then in that case, again, I need to think then which pipe is compatible with hardwood. So these are the things when we came across or we have information. So that will be because we are the one again will be designing or will be deciding that, okay, this category of pipe can be used because of this system. So that is what we'll be seeing in the chapter number 4. And apart from this, chapter number 5, we'll be dealing up with the basics of the fluid mechanics. Very interesting. First of all, we'll be learning what are the types of the flows over here, like laminar and turbulent. Then we'll be seeing what are the different kinds of the water. Then the most important thing is continuity equation. On this, the complete plumbing depends. That is Q equals AV. We all know this. Q is nothing but the flow. A is cross-sectional area and V is the velocity. So we'll be seeing parameters and we'll try to apply in maximum cases because as I said, plumbing is completely dependent on this. Okay. So you can see there are some examples done after that, and Hazen-Williams formula is there, which we'll be using for the pressure drop calculations, because we all know that as the material changes or the internal surface of the pipe is rougher or smoother, what happens? It has less or more number of, I can say, the pressure drop. So that is what we'll be seeing over here by means of Hazen-Williams formula or friction table. You can see here an example of pressure drop through pipe. We'll be seeing one example like how pressure drop will be affected if with respect to the pipe roughness, that is internal. We'll be seeing this. Then we'll be seeing is Manning's formula, which is used for the drainage side. This continuity equation for the water side. This is for the drainage side. Chapter number 6 is very important. So we'll be learning in what are the modes of the water which enters into the building. So now we will be learning like four to five systems over here. So that if I know the systems, then I can say or I can suggest that this system is most feasible in this project. Because if you know there's some circumstances or some boundaries, like in simple, if I say, if you know this, how often the water is being coming from municipal, I can say. Okay, and what is the pressure available from the municipal? If you have some parameters in this, so you can make your mind or you can take the decision, okay, that according to this parameters is fitting with respect to this kind of the water supply system. So I can opt this. Okay, so unless and until we don't know this, I can't make our mind that either I need to go with what kind of system of the building, okay, to supply the water. So we'll be learning what are the different kinds of the water supply systems can be arranged in a building. After that, chapter number 7 will be dealing up with the fixture units. So first of all, we'll be finding out what exactly is a fixture unit. So chapter number 7, we'll be seeing what exactly is a fixture unit, what exactly the fixture unit refers to, because in previously we have seen what is a fixture. Now, what is fixture unit? We'll be seeing it, and how fixture unit is common in the water side and drainage side we'll be seeing. Then we'll be dealing up with some theory. After that, we'll be dealing up with the manual pipe sizing with respect to the water side. Okay, so we'll be first of all learning the continuity equation we have already learned. Keeping that in mind, we'll be proceeding up with how to move on with the pipe sizing in a manual form by using IPC standard. Remember this, okay? Or we can go with different standards also. As you can see over here, there are a number of things like predefined pipe sizing and all this. So we'll be dealing with manual cold and hot water pipe sizing as per IPC standards. So manual cold water, manual hot water, manually I'll be dealing that how exactly you people need to find out that how you people can find out the pipe size if you don't have Excel program in your company. Okay, if they have not provided, it's not there, but still you can find out the pipe size with respect to the manual form by using some charts and tables. So this is what we're going to learn in the chapter number 7. So that is first of all the fixture units, what is fixture unit, and the manual pipe sizing, how you need to deal up with. But before that, some theory. So this was about the chapter number 7. And lastly, in the chapter number 7, I'll be doing the same example with respect to the manual, so that you have an idea what was the comparison. We'll be doing the comparison. Okay, we did it in manual form. Now we did it into the actual form. So you can see this. What is the difference between this and this? Okay, why we are teaching you in terms of Excel program? Because if Excel is not there, you can directly deal with manual, but manual is somewhat more safer side or higher side, you can say. But there are some drawbacks, disadvantages too of that. We'll be coming across and we'll doing the comparison with respect to that. Okay. Chapter number 8, this is very important because whenever you start with any kind of the project, you need to estimate the total water demand with respect to the project. Now, this can be like known by means of two methods. One is people method and another is public method. I mean, occupancy or area method, I can say. So just make sure or remember this. Okay, so remember everyone. So this is the very first step we are moving towards the designing. So chapter number 8 is we are here to find out that how much water is being demanded for this complete project. Now that depends on the project to project. Okay, because we know this. If it's like industrial or commercial, if I tell you about, okay, if I'll tell you about industrial or residential, obviously industrial demands more water demand. So there are two methods to find out the water demand. Okay, one is people method. Okay, I'll be using it for the private, and I'll be using it by means of, I'll be doing that by means of manual and Excel. An area method, I'll be using it for the public applications, and that I'll be using from again manual and Excel. So after that, when I find out the water demand, my main intention is to find out what is the average and the peak water demand. What is this average and peak? We'll be seeing later on. As of now, just remember water demand, minimum and maximum water demand, what we are here to find out in chapter number 8. Chapter number 9, we are ready for the project because every basics has been done. We have done some sizing also and all this. So chapter number 9 will be dealing up with the villa project A, as I said you. So we'll be dealing up with the complete villa project A pipe sizing. So pipe sizing in the sense, first of all, we'll be reading out the layout. Okay. Then we'll be doing the routing. Try to read, understand the drawing, then routing. Then we'll be moving on with the pipe sizing. With respect to the Excel program, as we have selected for this villa project, it's a central system. So there will be 3 pipe sizes. One is like cold water, okay, supply. One is hot water out and hot water return because it's a central system. So we'll be dealing up with 3 different pipes like cold water, hot water, and hot water return. So you can see cold water pipe sizing, hot water pump sizing, and hot water returns pipe sizing. You can see here cold water pipe sizing, hot water pipe sizing, and hot water return sizing. Then we'll be moving on with pipe size for peak demand. So what do you mean by this again? If you are dealing with the pipe size, which is with respect to the peak, then how you gonna deal up with? Because I'll say you when it's coming peak over here. Just for your information, everyone, right now, what we are dealing with the plumbing industry is right now what I'm talking about residential. We deal with maximum cases is the pipe sizing with respect to the probability. Now, what do you mean by probability? The chances. Okay. But we come across some projects which is not based on probability because of some cases. I'll elaborate that later. So that should be designed on peak because the values which is being given in this, I mean, in the application handbooks is on the probability. That means the chances of the working of the fixtures. But if the chances of the working fixtures is all working, then in that case, what you need to do, because it's not given when the fixtures is working all, then what you need to do, because the values which has been given in any of the code is based on the probability. Okay, because plumbing works on probability only. Plumbing always, remember, designed on the probability basis. Everyone following? So I'll be letting you know, like example, if you came across such kind of situation, then how you need to deal up with. Okay, so I'll be training you for pipe sizing for the peak demand in the chapter number 9 with respect to the project. Now, chapter number 10, again, we are dealing with water hammer arresters. So again, I'll be taking the reference of this chapter number 9. That is for the project I'm saying, villa project. So we'll take one small example from the project and we'll try to do the sizing and selection of the water hammer arrestor. You can see sizing is there and placement is there. That means placement, sizing, everything we'll be doing with respect to the project in the chapter number 10 for the water hammer arrestor. Chapter number 11 is the tank designing. Again, I'll be doing the tank designing with respect to the chapter number 9. That is nothing but the villa project once again. So in that villa project, if there was a tank sizing, so how much capacity of the tanks should be there? Underground, overground, or whatever, or rooftop. So we'll be dealing up with these tanks, how to deal up with this again. And most important, again, I'll be dealing this with respect to IPC standards, or you can see NVC standards or public health engineering. So I can define or I can derive this, or I can find out or do the sizing of the tank sizing with respect to 3 standards like NVC standards, you can see, or IPC and public health engineering. NVC is local, that is India. IPC is international. Public health engineering also is local from Odisha. So I can deal up with this. So in this here, you will be learning all about tank sizing. Underground tank sizing will be dealing up, roof tank and loft tank. So these are the 3 tanks what we will be sizing it. And not only this, we'll be sizing number of things over here, like vent pipe will be sizing, or drain pipe will be sizing, and we'll be sizing the overflow pipe also. A number of things, number of a huge theory for the tank sizing we'll be learning it about in the chapter number 11. Chapter number 12, again in the water side, we'll be dealing with the water heater sizing. So we know this, there are different kinds of water heater. One is like geyser, one is central heater, and one is solar heater, what is right now going in the market. So we'll be seeing all three heaters, how to design. So we'll be finding out what should be the capacity with respect to the villa project again, once again. So we'll be taking again the example of the villa project, and we'll try to say that if this villa was having central heater system, then what would be the capacity of central heater, electrical I'm talking about right now, what would be the central electrical water heater size? Okay, like we know this, like this much of gallons or this much of liters. Okay, so we'll be sizing with respect to the central, we'll be sizing with respect to the individual, we'll be sizing with respect to the solar. So always remember, we'll be sizing three different heaters for this same villa project in the chapter number 12. And not only this, we'll be finding out the kilowatt, because kilowatt is the responsibility of again a mechanical graduate, because this is what it was being transferred to the electrical engineer, so that he does the load calculation and he allows that much of the wire, I can say, or the capacity of wire which can hold up that much of kilowatts, because we know that that much of electricity consumption is being used, or it will be used by that heater to heat the water. Okay, this was about electrical heaters. Solar we don't, because solar is something different concept. Solar does not use electricity. Okay, so this is in the chapter number 12. The chapter number 13 will be dealing with the pump sizing first of all. So in this, we'll be learning about some basics. What are the types of pumps? Then we'll be learning about what are the kind of pumping systems. I mean, there are two loops, and closed or open. We'll be seeing this. Then afterwards, we'll be moving on with sizing. Now, again, we'll be taking villa project as a reference, and we'll be sizing one pump. That is, for example, I'll size one transfer pump, while I'll transfer, or once transfer pump is sized, I'll be taking villa C as an example, because in villa C is a booster set installed over there. So I'll be taking that calculation. We'll be dealing that calculation, and after that, we'll compare that what actually is being done and what we have done. So we'll try to compare whether we have done or right or wrong. So we'll be dealing up with the transfer pump sizing. We'll be dealing with the booster pump sizing. We'll be dealing with pressure tank sizing. Okay, that is pressure vessel, you can say, and hot water circulating pump. And we'll be dealing with one more pump, that is gravity plus booster, which is kept at the rooftop. We'll be dealing in that case. Like for example, okay, I'll not elaborate. When we deal with the chapter number 13 in detail, we'll be dealing. So we'll be seeing number of pumps and pressure tanks over here, how to size. That means we are here to find out that how much horsepower of the pump is being needed for this project. Chapter number 14, the last one, we'll be dealing with the garden water sprinkler system. So this ends with the water supply. Now the phase 2 of the plumbing, that is with the drainage. So drainage is not so lengthy and not so difficult. So this is simple. First of all, we'll be having some theory. Then we'll be seeing what are the different categories, like what is soil pipe and all this, or vent pipe or waste pipe. So we'll be seeing this classifications, and we'll try to learn what exactly this refers to. Okay, that means what pipe carries what, so what that pipe is called. So we'll be seeing this. After that, we'll be seeing is what are the stacks. That is again basics, like risers, I can say. After that, we'll be seeing there has been traps used just to maintain what? The water seal, so that it does not allow the bad smell, and it does not allows what? Because it maintains a water seal. That means it does not allow the backflow and to restrict the bad smell entering into the atmosphere. So we'll be learning what are the different types of traps. After that, again, we'll be sizing the size of the traps, then maintaining slopes, because drainage is completely based on slope, 1% or 2% we'll be seeing. We'll be learning about unit of slopes. Then we'll be dealing with the manual sizing, drainage pipe sizing. Like same wise, I can say we have previously seen, we have done in the chapter number 9 project, there was water supply sizing. Here is a drainage sizing, that is drain pipe sizing. We'll be dealing up vent pipe and rainwater system sizing will be seen, design of septic tank, and design of grease interceptor or grease trap. So these are the things what we're going to learn in the complete plumbing design. I hope now you people got a complete idea and overview what are the things you're going to learn over here. So inshallah, when you are done with this, you people can be capable enough, I can say that, or you will be familiar enough with the service that how you need to deal up with this. Okay.